Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 5, Lesson 14. Let's get started. All right, example 1 is kind of a throwback to last lesson, where we just have to find the volume of the rectangular prism. And I talked to you last lesson about using the formula volume, or the equation volume equals the area of the base times the height. And in this case, they gave us the area of the base. So that's 9.5, that's 19 halves if I make it an improper fraction. And then I would multiply that by the height, which is h, and I don't know what that is, so that's going to stay in h. And they told me the volume. The volume of the sandbox is 7 1/8 cubic foot. 7 1/8, that's 57/8. So that's my volume. I'm going to put that right here. 57/8 is the volume, and I know the area of the base. I don't know the height, so what I'm going to do here is multiply by reciprocal. And if I do that, that means I'm going to multiply both sides by 2/19. So 2/19 on that side, multiply over here by 2/19 as well. And the 19s cancel, the 2's cancel. I'm left with h equals, that's going to be our height. And then if I can, I'm going to simplify. So I know 2 goes into 2 one time, and 2 goes into 8 4 times. So I get 57 on top. I don't think 19 and 57. Well, maybe 3 times, right? Let's check that. I think that 57 divided by 19 is going to be 3. Let's see. Yeah, 3. So this 19 goes into 19 once, and 19 goes into 57 3 times. So I get the simplified answer, which is 3/4, and that's in feet. So the height is 3/4 of a foot. So again, we're just using the equation for volume, substituting what we know, and then using algebra to solve for what we don't know. All right, let's move on. That sandbox was filled with sand, but after the kids played, some of the sand spilled out. Now the sand is at a height of 1/2 foot. So a 1/2 foot instead of what we had determined, which was 3/4 of a foot. So this is going to be a little bit different now. We're going to take the area of the base, which was 19 halves. So let's go back here. We're going to say volume is equal to 19 halves. That's the area of the base. And then multiply it by 1/2 to get our new volume instead of the 3/4. And that gives us 19/4 cubic feet. So feet cubed. So again, volume equals area of the base times the height is the new volume. All right, so let's move on. Now we get to what we're doing this week, and this is composite volume. So we've got not a rectangular prism anymore, but we do have, we can cut this and decompose it so that we have 2 rectangular prisms. And so what we're going to do is find the volume of this first rectangular prism, the one on the side here. And then we're going to find the volume of the second rectangular prism, the one on this side. And when we do that, then we'll have, we can add those 2 together to get the composite volume. So let's start with the one on the left. We'll call it the volume of the left. And in order to calculate volume, I need 3 dimensions. I need a length, which is going to be here. That's 2 3/4. So 2 3/4 is going to be 11/4 times the width, and the width is this diagonal line here. That's 2 meters, so that's times 2. I'll put that over 1, so we've got all fractions. And then I need a height, and the height is going to be this dimension, which we see over here. It's 1/5. So multiply that by 1/5. And let's see if we can simplify. It looks like we can. let's see, 2 goes into 2 once, 2 goes into 4 2 times. And that's it. So we just multiply now. The volume of the left side is going to be 11 times 1 times 1. That's 11 for our numerator. And then 2 times 1 times 5, that's 10. So 11 tenths meters cubed. That's the volume of the left rectangular prism. And now let's work on the right. The volume of the right side is, well, I need this length. That's 9/4 meters times the width is going to be here. That's 4 1/3. That's 13 thirds. And then the height is the same. It's 1/5. So there we have those. And then let's see if we can simplify. Yeah, I can simplify there. I see that 3 goes into 3 once and 3 goes into 9 3 times. And then I can do 13 times 3, that's 39. So I get the volume of the right side is 39 over 4 times 1 times 5, that's 20. So 39/20 meters cubed. And now the part that nobody likes, and that is adding fractions. And the reason it's a little tougher is in order to add fractions, your denominators have to be the same. So right now I've got tenths and I have 20ths. So I want to make them the same. And I can do that by taking this 11 tenths and multiplying by 2 over 2. And if I do that, I get 22 20ths, and that's an equivalent fraction. And notice that all we're doing here is multiplying by the number 1. And we learned earlier this year that when you multiply by the number 1, you get the same answer. That's the multiplicative identity property of 1. So we have an equivalent fraction, and now I can add them. I can add 39 20ths. Let me move this here for a second. 39 20ths plus 22 20ths, and that's going to give me 39 plus 22 is going to be 61 20ths, and that's meters cubed. And that's the volume of the entire composite figure that we have there. All right. So we're just cutting it up, decomposing it, and adding the two volumes together. All right, exercise 1, back to just finding volume. Volume, let me move this up a little. Volume equals area of the base. Well, the area of the base is here. That's 4/5. Let me just put area of the base times height. And the volume we know, that's 35/15. 35/15 equals the area of the base is 4/5. And the height we don't know. So that's going to be h. And then this is where we multiply by reciprocal. I'm going to multiply this side by 5/4. I'm going to multiply this side also by 5/4. And when I do that, that gets rid of my coefficient. I get h all by itself. That's what I want. And then I'm going to simplify if I can. 5 goes into 5 once. 5 goes into 15 3 times. And we have, that's it. So it's 35 is our numerator, and 12 is our denominator. 35/12 yards is our answer. That's the height. Okay, exercise 1B. Same thing here. We've got the volume equals 45/6. And the area of the base we don't know now, so we're going to leave that in A. But we do know the height, and the height is 9/2. Okay, so we have that from our volume formula. And then I'm going to multiply by reciprocal, both sides. Remember, whatever you do to one side, you have to do the other side. That's from our algebra work. The 9's cancel, the 2's cancel. I get A, the area of the base, equals, let's see if we can simplify. 9 goes into 9 once, 9 goes into 45 5 times, 2 goes into 2 once, 2 goes into 6 3 times. So we get 5/3, and this is an area, so it's meters squared. 5/3 meters squared is the area of the base. That's part B. Okay, number 2. Marissa's fish tank needs to be filled with more water. Determine how much water the tank can hold. That's the volume of the entire tank. So let's do that first. Volume of the entire tank. Well, I've got length is here, 3/4 of a meter, times the width is 1/4. So that's the width, and then the height of the entire fish tank is 3/5. So this will tell us how much water the fish tank can hold. I don't see any simplifying that I can do, so we're just going to multiply. 3 times 1 times 3, that's 9. And 5 times 4 is 20, and 20 times 4 is 80. So it's 9/80 meters cubed. That's the volume of the entire tank. Okay, and then next, determine how much water is already in the tank. So that's the blue part. And we're going to do volume again. Volume equals, well, the length stays the same, 3/4, and the width stays the same, that's 1/4. Only our height changes. The height is now 3/8 of a meter, so we're going to multiply this time by 3/8. And again, there's no simplifying that can be done, so 3 times 1 times 3 is 9. And on the bottom, I've got 4 times 8 is 32, and 32 times 4. 32 times 4 is 132, I think. Let's just make sure. 32 times 4, 128. Of course, 128. And that's meters cubed again. So there's the volume of the water that's already in the tank. And then the last question is, how much more water is needed to fill the tank? Well, we can do this in a couple of different ways. We can find the height of the empty space up above and use length and width again. Or we can take the volume of the entire tank and subtract away the volume of the water, which looks like not a lot of fun because we'd have to make those denominators the same, and that does not look easy. Those would be some big numbers. So what I'm going to do is I'm going to find out what the height is by taking the original height over here, 3/5. I'm going to take 3/5, and I'm going to subtract away the height of the water, which is 3/8. Now, still we need to do some work because the denominators aren't the same. So, but they'll be much easier numbers. So I'm going to make both of these denominators into a 40, and then we should be able to get some subtraction going. So in order to make this 5 into a 40, I have to multiply by 8/8. And in order to make the 8 into a 40, I'm going to multiply by 5/5. That gives both our denominators 8 times 5 and 8 times 5, that's 40. And then we just multiply the numerators. 8 times 3 is 24, and 3 times 5 is 15. So what we get is 9/40 for a height. And so that's the height. This is the height here, right there. So then to find that volume, we're going to go volume equals 3/4 is the length, times 1/4 is the width, times 9/40 is our height, and that will give us the volume of the empty space. Let's see, still no simplifying. So 3 times 9 is 27. And 4 times 4 is 16, and then 16 times 40 is 640. So it's 27/640 cubic meters is the empty space, how much water is needed to fill the tank. Okay, so again, just using that volume equation to calculate volume. Right, let's go to number 3, determine the volume of the composite figure. Okay, so I'm going to cut this one here. So we're going to make a left side and a right side again. And so let's do the volume on the left side over here. The volume is length 2 times the width is here, that's 12 meters. So it's 2 times 12 times the height, which they gave us over here, 3 1/4. And that's going to be 13/40 fourths. And let's see, we can simplify here. 2 goes into 2 once, 2 goes into 4 2 times. And then 2 goes into 2 once, and 2 goes into 12 6 times. So looks like we're going to have a whole number. So the volume is 6 times 13, which is 78. 78 cubic meters. That's the volume of the left side. And then let's do the volume of the right. The volume of the right is going to be 9 1/2. So volume equals, that's 19 halves times 2 1/3 is 7/3 times our height, which we said was 13/4. And let's see if we can simplify anything. Looks like no. So this is going to be some big numerators. At least the numerator is going to be big. 19 times 7 times 13. That's 1,000. So the volume is 1,729. And the denominator is 2 times 3 is 6, times 4 is 24. So 1,729 24ths meters cubed is the volume of the right side. And then we need to add them together. Well, since it's already in a fraction here, that I'm going to make this one into a fraction too, this 78. So instead of 78 over 1, I'm going to change it into something over 24. So I'm going to multiply by 24 over 24 so that our denominator becomes a 24. And the volume of the left side then is going to be 78 times 24. 78 times 24 is 1,872 24ths. And we're going to add that to the right side, which is 1,729 24ths. And that's going to give us our total. When I add the 1,729, I get 3,000. So let me put it up here. The volume of the entire thing is 3,601 24ths meters cubed. That's the composite volume of the entire figure. Okay, split it up into 2 rectangular prisms. Find the volume of each, add them together. And the last one for today. Oh, it looks fun, right? So I'm going to cut it here. We'll have one on the right side. I'm going to cut it there. We'll have one in the middle, and then we'll have one on the left side. So we're going to have 3 different ones. Let's do the volume of the right side first. Volume of the right side. Well, I've got 1/4 is the length. I have 1 1/4, that's 5/4 is the width, and the height is 3/4. So no simplifying, doesn't look like. 5 times 3 is 15. 4 times 4 is 16, and 16 times 4 is 64. So we have 15 64ths cubic feet for the volume on the right. All right, volume in the middle. Let's do that one next. Let's go volume in the middle. That is, let's see, I've got a half foot for length. And then the width, well, it's 5/4 is the entire distance, but we need to take off 1/4, which is that little piece right there. So 5/4 minus 1/4 is 4/4, which is just 1. So we're going to multiply by 1 over 1. And then the height is still 3/4. Okay, and then this is pretty easy. I can just multiply. 1 times 1 times 3 is 3. And 2 times 1 times 4 is 8. So 3/8 cubic feet is the volume in the middle. And then lastly, we get the volume on the left side. Let's see if we can fit it down here. Volume on the left, is this distance. Well, that distance is this entire back piece, 1 1/2. So let's do that on the edge here. That's 3/2. And then we want to subtract this 1/4, and we want to subtract this 1/2. So minus 1/4. Let's do the 1/2 first. Minus 1/2. That's going to leave us with 2 halves. 2 halves, which is just 1. And then we need to subtract 1/4. So 2 halves, I can also make 4/4. And then I can subtract 1/4, giving us 3/4. So the length is 3/4 times the width. Well, the width they gave us here is 1/2. And the height is still 3/4. So again, we just multiply and we get 3 times 1 times 3, that's 9. And 4 times 4 is 16, times 2 is 32. So 9/32 cubic feet. All right, now we need to add those. We need to add this one to this one to this one.